Hi, now let's discuss CodeChef 156 contest partition score question. The question says that the array is given to us of size n, and we have to divide this array into two disjoint sets or arrays. Two disjoint arrays. Let's name it as S1 and S2. We have to divide that one single array into two disjoint arrays. Disjoint is nothing but when we combine those values, we should not get any value. That means the elements of S1 should not be equal to elements of S2. Even a single element should not be equal to elements of S2. Those two should have different elements itself. Now we are also given a K element. This K says that S1's size should be greater than or equal to K. Size of S1 array should be greater than or equal to K. That means it should have at least K elements in S1. And in S2 also the same condition is applied. That is, S2's size should be greater than or equal to K. That means at least K elements should be present in S1 and as well as S2. Let's see this. And the return value should be a score value. That is, score is defined as maximum value of S1 plus minimum value of S1 plus maximum value of S2 plus minimum value of S2. Now we have to return maximum score. That is, how much we can maximize this score, we have to maximize that much, and we have to return the maximum score as possible. That means we have to maximize this value. Let's take an example and see how this actually works. Let's say we have A as 1, 2, 3, 4, 5, and 6. And K is equal to 3. And our size of K is equal to 3. That means as we have 6 elements, we can say that in first S1, let's name this. S1 will have some elements, S2 will have some elements. Right? How many elements? As at least 3 elements should be present. If we place 3 elements in the first, if we place 3 elements in the first S1 array, we have to place next 3 elements in S2, right? The minimum value is 3. So we have to maintain 3, 3. As after maintaining 3, 3 here, the array size is completed. So these will be the elements in the S1 and S2. How we can place these values? First, we have to maximize this value. That means maximum of S1, maximum of S2, minimum of S1 plus minimum of S2 should be maximized. So what basically generally we do, the maximum element will place in one array. Let's say we are placing that in S1. The maximum element will be placed in S1. And if we see the next maximum element we can place in S2, right? Isn't it? If we have maximum here and the second maximum here, we can somehow increase the sum value. And if we take, let's say we are placing 1 here, 2 here, 3 here, and 4 here. If we see the sum, 1 plus 6, here it is 1 plus 6, and there it is 2 plus 5. That is 7 plus 7, that is 14. Is this the maximum value? Can we have some other combination like this? Let's say the maximum values are kept as it is, and second maximum is kept as it is. The next values, if we take 3 and 4 here and 1 and 2 here what we are doing, we are trying to maximize the minimum value. We are not keeping 2 here, we are keeping 3. We are trying to maximize minimum value in one array, in one or the other array. We are taking S2 here, so we are trying to maximize the minimum value. So what we did here, we placed 3 here. This is the case. So what we can generalize from this, in this case, what we can generalize, if we have, let's say, here what will be the sum? Let's see the sum first, then generalize it. What will be the sum? 7 plus it is 8, right? 7 plus 8 is 15. We got some other big value. We can't place some another combinations which can give maximum answer than this. This is the worst case we can place. Now, let's say if we have array as A1, A2, A3, and so on, AN, what will the S1, S1, S2, what can be the values here? What can be the values here? In the first one, we can place the maximum value. In this also, we did the same thing. We place the maximum value here. So we can place the maximum value in one array. We can place the next maximum. That means max 2. Let's take the first maximum as max and second maximum as max 2. We are placing in the second array, right? We are placing that in the second array. In the above example also, we did the same. Now, if we see, if we want to place the values, here if we take what is happening here, if we take the max one value in this array, we can take the minimum value as it is. Like how we did here, we took the minimum value as it is in one or the other array, that will be the minimum. So we can take it here or here. I'm taking it in the S1. So minimum value will be placed in one array. So in the next array, what can we place? Can we place minimum 2? We did the same thing here, right? When we did the same thing here, when we placed the second minimum value here, we did not get the maximum answer, right? We did not get the maximum answer. So we can't place the second minimum here. Then what we have to place here? What we have to place? We can place, let's say this is min 1, min 2, min 3. Let's say we are trying to link this minimum values and maximum values using k. That means we are placing kth maximum element in max 2. That means we have to fill this S1 with k elements, right? What will be the k elements? If we take k as 4 here, the first element is here, next 3 elements are here, right? When we take that, when we place the k elements in this array, the next n minus k elements will be placed in second array, right? If we place the first k elements in the first array, the next element, that is k plus 1th element, we can place here, right? The k plus 1th element we can place here. What will be the k plus 1th element? That is min of k plus 1. Sorry, this would be the max of k plus 1, because if we see from here, the second maximum is placed here. If we sort the array, after sorting, we can take maximum of k plus 1, max k plus 1th element. That can be minimum also, because when we are coming from in the other direction, that will be k n minus kth element. If we are going in other direction, it will be k plus 1th element. That means we are placing k elements in the first array. The second array will have the elements from k plus 1. So k plus 1 will be placed in this. That will contribute to the maximum answer. Let's in the above example, what are those values? 1, 2, 3, 4, 5, 6. As this is already sorted, this will be our max 1. This will be our min 1. What is the k value? Our k value was 3, right? Then what I said here, k plus 1th value, that means fourth value. If you see the fourth value, fourth maximum value, that means max 2, max 3, max 4. And let's take this as, I'm sorry, I'm writing it in the reverse direction. Max 1, max 2, max 3, max 4. As we got k plus 1th value, let's take here from minimum, min 1 and min 2. If you see what we placed in the S1 and S2 here, this is the k plus 1 maximum, right? Is this the k plus 1 maximum? What is k plus 1? K plus 1 is 4 in our case, right? Is this the fourth maximum value? Yes, it is. As is this condition satisfying in the above example we have taken? Yes, it is satisfying. So what will be the maximum value here? We have to take this value, this value, this value, and the in this minimum value should be max of k plus 1. That means here we will have max 3 and it will reduce to k plus 1, right? So we can, in the second array, minimum value will be the max of k plus 1. What will be the answer here? The answer would be, in this case, if we take, in this case, what will be the answer? In the array, max 1 plus min 1 plus max 2 plus max k plus 1. Right? Isn't it the answer? In the array, how we can represent this after sorting? After sorting, how we can represent this? A of the maximum value will be stored in n minus 1th index, right? If you see here, the maximum value will be stored in the last index. So it is max 1. Min 1 will be stored in A of 0, right? The minimum value will be stored in A of 0. Max 2 will be stored in A of n minus 2. That is the second last element from in the array. And the max k plus 1 will be stored in A of n minus k plus 1. As I said before, if we take in terms of minimum, it will be n minus k plus 1. That is, as we are sorting that, it would be from left to right. So this will be n minus k plus 1. That is 6 minus 4 plus 1. That will give you 2 plus 1. That is 3. So in the third index, we'll have this value. So this is the formula for the value. Let's say here we have an exception. Let's see with that exception with an example. Let's say our k value is 1 and the array is some around 5, 3, 6 and 7. If this is the case, if k is 1, in S1 what will place S1 and S2? In S1 what we can place? We should have at least one element, right? In this one element, in this one element. Rest elements can be anything. So if we place the first maximum here, second maximum here, and let's say we are placing these randomly, here what will be the answer? 7 plus 5 would give us 7 plus 5 would give us 12, and 6 plus 3 would give us 9. If we add this up, the answer is 21. I'm saying this answer is wrong. Let me prove why it is wrong. As k is 1, I can take only one element in S1, only one element in S1, and in S2, I can place the rest of elements, that is 6, 5, and 3. If I do this, the maximum element in S1 and minimum element in S1 is 7, right? The sum is 14. Here, the maximum element is 6 and minimum element is 9. Here, 23 is the output. We somehow increased our output, right? If we have only one element in one set, that is k is 1, we have somehow increased our value. If we place the second maximum value here, also will not get the optimized answer, right? The maximum value. So we have to place only one element when we have k is equals to 1. If k is equals to 1, what will be our formula? Like here we derived a formula, right? For this, now how here our score will have, that would be max 1 plus max 1, as we are taking only one element, max 1 plus max 1. And in the second array, we are keeping the second maximum element. So this will be the max 2 will be the maximum value there and minimum value will be as it is. So if I see here, the maximum value will be n minus 1 plus a of n minus 1 plus max 2 will be a of n minus 2 plus a of 0. This is the exceptional case when k is equals to 1. We can directly write the conditions as this. After reading the array, if k is equals to 0, sorry, 1. If k is equals to 1, We can write this formula here directly. Else, we can write the above formula, right? We can write this one. We can write this one, isn't it? This is giving our solution, right? We can write this one. And if k is equals to 1, we will write this one. Now, what will be the time complexity for this? Did we use any loops here? We are just writing an if and else condition by making some observations. So the time will be constant. Even the space will be constant because we are not using any extra data structure to solve this. Thank you.